For centuries, scientists debated the nature of light. Some claimed that light was a wave behaving like a ripple in a pool. The opposing view was that light was a particle, like the droplets of water that flow from a kitchen faucet. Just when a prevailing view gained momentum, evidence for the other caused confusion. Finally, in the early 20th century, Albert Einstein called a tie. Light is both wave and particle. Those who believed in the particle theory of light followed Sir Isaac Newton. He described light as a series of particles using a prism to prove his theory. To Newton, the clarity and sharpness of the prism shadows meant that light traveled as a shower of particles, each following a straight line until disturbed. Those who opposed Newton's theory followed scientist Christian Huygens, who cited light's diffraction and interference as proof that it is a wave. Diffraction, the bending of light as it passes around an object, and interference, when waves combine to form greater or lesser amplitude, occur in other mediums with wave-like properties such as sound and water. Astronomers studying moving galaxies prove that light follows the Doppler effect, the name for the change in sound as waves from the source move closer or farther away from you, elongating as they move away and shortening as they come closer. Visible light, as seen in the colors of the rainbow, exhibits similar properties, with longer wavelengths appearing as a red shift and shorter wavelengths as a blue shift. Until the turn of the century, this overwhelming evidence convinced most scientists that light was a wave, until Albert Einstein settled the score. One thorn in the argument for light as a wave purist is a phenomenon called the photoelectric effect. When light shines on a metal surface, electrons fly out, but higher intensity of light does not cause more electrons to be released, as you would expect with the wave theory. Albert Einstein studied this effect and came up with a compelling theory that stated light was both wave and particle. Light flows toward a metal surface as a wave of particles, and electrons released from the metal as an interaction with a single photon or particle of light, rather than the wave as a whole. The energy from the photon transfers to a single electron, knocking it free from the metal. Einstein's declaration of wave-particle duality earned him the Nobel Prize in Physics in 1921. Since Einstein's discovery, physicists have embraced this theory. Einstein declared we have two contradictory pictures of reality. Separately, neither of them fully explains the phenomena of light, but together they do. Understanding light as a wave led to the development of important technology such as lasers. The discovery of photons made possible the electron microscope. And thanks to Albert Einstein, we can stop this centuries-old debate and declare everyone a winner.